ever at school. Today's video is going to look at bile, and we're just going to briefly discuss bile, its functions, its components, and hopefully you'll have a better understanding of what bile is at the end of the video. So bile is a watery mixture of organic and inorganic compounds. The most important components of bile are phosphatidylcholine, which is otherwise known as lecithin, and bile salts, which are conjugated bile acids. The following video on from this will be looking at bile acids and bile salts, so if you don't understand that just yet, just bear with us. Watch this video and then watch the following videos after this, and hopefully it should make sense. So bile, as we previously just mentioned, is a watery mixture of organic and inorganic compounds. So this bile can pass from the liver, and it's produced inside the liver, into the duodenum via the common bile duct, or it can be stored in the gallbladder when it isn't needed immediately for digestion. So we can see here is the liver, and this is where the bile is produced. It passes into the duodenum via the common bile duct, or it can be moved into the gallbladder and stored in the gallbladder, and when it is required for digestion, it can pass through the common bile duct into the duodenum. So what are the functions of bile? The first one is to emulsify fats. This means it breaks down the fat molecules from a high surface area to from a low surface area to a much higher surface area. So it breaks them down into smaller droplets so that the enzymes can work on it. It also neutralizes the acid from the stomach. Bile is an alkaline solution, and the acid in the stomach is obviously acidic, so it will in turn neutralize this stomach acid. Also, bile salts will act as bactericides and destroy the microbes in food. And finally, we're going to discuss this in a separate video, but I'm just going to mention it here now because I don't want to leave it out. Bile is a route of the excretion of bilirubin, which is an important component of hemoglobin, but we're going to make a separate video on that. So this is everything I want to discuss today on bile. Watch the following videos on from here. They'll be looking at bile acids, bile salts, and lipid digestion and absorption. Thanks very much for watching, and I hope this video was useful.
Bile is produced in the liver, and that bile is drained from the liver through the hepatic ducts. There's a right and a left hepatic duct. These hepatic ducts unite to form the common hepatic duct, which can conduct bile down to the cystic duct, where it can be stored for later release by the gallbladder. A continuation of the junction of common hepatic duct and the cystic duct is known as the bile duct or the common bile duct, which descends down in the hepatoduodenal ligament and is joined by the pancreatic duct to form this dilation called the hepatopancreatic ampulla. That hepatopancreatic ampulla moves through the major duodenal papilla, where these secretions are released into the second or descending part of the duodenum. Shown here are the contents of the hepatoduodenal ligament, keeping in mind that hepatoduodenal ligament is going to connect the liver adjacent to the gallbladder with the duodenum. And the three major constituents of this hepatoduodenal ligament are the bile duct, or the common bile duct, the hepatic artery proper, HAP, which then divides into the left and the right branches of the hepatic artery proper, as well as the hepatic portal vein, which is draining all of the blood from the gastrointestinal tract and delivering it to the liver for processing. The gallbladder sits in close association with the right anatomical lobe of the liver, and it can be found inferior to this right lobe. The gallbladder's role is to store bile conducted through the common hepatic duct and cystic duct from the liver, which is why oftentimes the gallbladder in cadaveric specimens is stained green. The gallbladder has a fundus, although in anatomical position that fundus is inferior, a body, and a neck. And it's supplied by the cystic artery. The cystic artery is typically a branch of the right branch of the hepatic artery proper. It may also be a branch of the hepatic artery proper or a branch of the gastroduodenal artery, or may find its source from a variety of other vessels. That cystic artery is a very important artery to locate for the removal of the gallbladder, and it can reliably be found in the hepatobiliary triangle. That hepatobiliary triangle has the following sides. The superior portion, or side, is going to be the inferior surface of the liver. The medial portion is the common hepatic duct, and the inferior portion running alongside of the gallbladder is going to be the cystic duct. And so we can see that that cystic artery, regardless of its vessel of origination, is going to traverse that hepatobiliary triangle. In terms of its innervation, the gallbladder is innervated by the hepatic plexus. Thank you for your time. If you have any questions or a need in further visuals, please do visit the